Now that we've explored acids and their properties, let's do the same for bases. And so this is the same syllabus as we had before. It's just this first little section here about the properties of acids and bases. So let's check this out. The most common base that you guys have used to seeing, of course, from year 7 onwards is sodium hydroxide. And so we're just going to look at this one here for a second. I've got a picture of sodium hydroxide right there that I found. And look, it is not looking like that in real life. Remember, it is an ionic compound. So we have a cation and then we have a polyatomic ion here, or a polyatomic anion. Anion is negative charge. And when you have a crystalline structure, as you can see with these crystals here, you're going to have millions of these compounds together, because remember, ionic compounds form lattice arrangements. But if you look at the lowest unit number, you're going to have 1 sodium for every hydroxide. And so they've just represented it like this for sodium hydroxide. So here's some drain cleaner, which means it's very caustic. Remember, acids were corrosive and bases are very caustic. They do react very intensely with your skin. So with things like drain cleaner, etc., you want to make sure that you're very careful with that and that you don't get any on your skin. So let's have a look at taste. Well, they taste bitter. Remember, the acids taste sour, the good old sour lollies. Bases have a bitter taste to them. And you're probably most familiar with this, I guess, if it's in terms of hydrogen bicarbonate. And an experiment you do in the junior school, I know I do, is you make sherbet. And sherbet is where you get citric acid combining it with the base sodium hydrogen bicarb, which is bicarbonate or baking powder, right? And when you combine those two, they're two solids, so they need the saliva to dissolve the solids together to have the reaction to produce that fizz, that carbon dioxide in your tongue. But of course, it doesn't taste very nice unless you put some icing sugar in there. However, if you don't get the ratios right, if you add too much of the acid, it tastes sour. If you add too much of the base, it tastes bitter. So you've got to get the all proportions right there. So it has a bitter taste. Now, remember that bases release OH minus ions into solution. Well, that's the definition that we guys gave you, we chemists, teachers gave you in the junior school, because a lot of the bases you come across in the junior school are bases like that, really easy bases, and it's a sort of an easy concept to get your head around, that it releases OH minuses into solution. The more OH minuses you have, the more basic it becomes and the higher the pH. But of course, we're going to move on from that and have a more sophisticated understanding of what bases are in the next series of videos. And so that's why I put an asterisk there, just like I did with the acids, because we're going to come across scenarios and examples that bases have basic properties but don't have an OH minus ion. A common example that comes to mind is ammonia, right? And we're going to be testing ammonia in this video, and you're going to see it's going to have features of a base, but it's not got an OH minus ion. So we need to adjust our definition, right? But for all intents and purposes, this is pretty good. Then we have our pH greater than 7, so we're going to be exploring that. Bases feel slippery. If you ever touch sodium hydroxide when it's wet, a solution of it, it feels slippery to your touch. It's an electrolyte in water. Now, I didn't mention this in the acid video, but an electrolyte is just a solution that has the ability to conduct electricity. And what we do in the lab is we usually do a test like this, and we will be doing this later on in this module when we talk about degree of ionization. But basically what we're doing is we're getting a solution, we're putting 2 electrodes in there, and we're running a battery or electricity through that. And if the solution conducts electricity, if ions are allowed to move between these 2 electrodes, then a circuit is complete and the light bulb turns on. And so bases do break apart and dissociate to produce an electrolyte solution, certainly if we follow this definition. Okay, well, what about ammonia? Well, that's a little bit more complicated. We'll get into that later. Okay, but if we had a solution of ammonia, the same thing would happen, right? It would conduct electricity. But the reason why is we'll have to deal in another video. And then, of course, we have the good old neutralization reaction. So let's explore these quickly. First one is pH, right? We saw that previously this universal indicator chart for pH, the color told us the particular pH that a substance had. And if we have a look at some examples of common bases out there, seawater is slightly alkaline. Then we have like indigestion tablets, right? We're going to look at that in a second. Soapy water, so soap has got a very basic sort of feel to it. We've got drain cleaner, which I've already mentioned, bleach, ammonia, and baking soda. We've already mentioned the sodium hydrogen carbonate. So here's a quick little video of us testing these in the lab. So you can see we've got a Petri dish here, and in the Petri dish we're putting samples of different bases. And so we have a sample, I think what we used was ammonia and sodium hydroxide. And you can see that I've got some universal indicator paper, and when we touch a glass stirring rod to the I think it was the sodium hydroxide they used first, and we touched that onto the paper, the universal indicator paper was very, very dark, and so it's really quite basic, the sodium hydroxide, right? Then we touched it onto litmus paper, and remember, we might even color this in. If I have blue litmus, right, blue litmus is down here. If we had those blue and red litmus and we were to touch base to it, what happens? Well, the blue paper stays blue, so bases are blue in litmus paper, right? Because remember, it's all about the base, No joking. So, but what about the red? What about our red litmus paper? Well, if I just do a little dot there, a smaller dot, just to get rid of that. And we found that by looking at the video that it is actually turns blue. So pretty much blue in base. Blue litmus stays blue, red litmus turns blue. Well, what about their neutralization properties? Well, just like acids, they can react with each other to form a salt plus water, and heartburn is a situation in which this sort of chemistry is seen. And so you have a lot of excess acid being produced either by overeating or by nerves, etc. That acid slowly makes its way past the cardiac sphincter there, which is just a muscle there. It goes up into the esophagus. The esophagus doesn't have cells that produce a lot of mucus to prevent the cells being eaten by the acid, so the cells lining the esophagus start to feel that pain of the acid attacking them, and then of course you feel that heartburn. So what you do is you then take an antacid, which is a base. That base then neutralizes that acid and makes you feel a little bit better. And so this is what's going on here. We have a acidic solution, we add a base to it, we then end up with a neutral solution. As you can see here, the litmus paper is green, telling us the pH is back down to 7. So it's a neutralization reaction. So bases react with acids. And that's the end of the slides there. So that's some examples of some properties of bases. I hope that makes sense to you. You've taken plenty of notes, and I'll see you in the next video where we start learning how to actually name acids and bases. See you then. All right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.